Okay, this is example 13. The hypotenuse of a right triangle is 8 inches. If one leg is 3 inches, find the degree measure of each angle. So the first thing I'm going to do is I'm going to draw a little sketch of the given information. Okay, so hypotenuse has to be the longest side. This is 8. One leg is 3, so it doesn't matter if I choose this one or this one. Wants me to find angle A, angle B. Okay, and it doesn't really matter if I call this one A or this one B either, to be technical. But what trig function will help me be able to get what's given? So first of all, let's just look at A. What information is given to me? Which trig function uses both of these given information? So let's just start with sine. Opposite over hypotenuse. Now that was just really nice. If that didn't work, I would have tried the next one and then the next one. But sine of theta is going to be equal to opposite over hypotenuse. In this case, opposite is 3. This is so sine of A, angle A, is 3 over hypotenuse, which is 8. Now this trig function uses both given pieces of information, so that's good. Now, I don't want to know the sine of A. What do I want to know? What was asked of me? The degree of A. Okay, so what would I need to do? What property could I use to get A by itself? Right, so I'm going to jot this property down. So remember, if you have your sine inverse times the sine of x, you're just going to be given x. So in this case, if I'm willing to do, I'm going to save myself some room. So if I have sine of A is equal to 3/8 here. So if I take the sine inverse of each side, whatever you do to one side, do to the other, then right here's my property. Sine inverse times sine is just A, and that's what we were looking for. We're looking for angle A. So angle A is calculated by taking sine inverse of 3/8. And now this is where you go to your calculator, make sure it's in degree mode, and you do second sine, which should be this inverse function. And you should get the approximate value of 22 degrees. Okay. So my other thing is to find the degree measure of each. So I found A. Our next task is to find B. I have a couple options here. I can use trig functions in a like manner that will work with B, or what else can I do in a geometric sense? What did we say about our definition? Remember, A plus B is equal to 90 degrees. We recall A plus B is equal to 90 degrees, and this isn't using this is using a definition as well. So B, if I solved for B, it would be 90 minus A. And we know A. 90 minus A is 22 degrees. So angle B would be 68 degrees. Okay, that's using that property. If I use the trig definition, it would be, if using this angle B, adjacent over hypotenuse is defined to be the cosine. So I would say cosine of B is 3/8. Use my property for cosine here, which is multiply both sides by cosine inverse, cosine inverse. Angle B is just going to be, this was rounded, it's actually 67.97 dot dot dot, but we round it. So you can see that this is consistent right there. So you only have to use one method or the other, but okay, example 14, a right triangle has a hypotenuse of 6 inches. If one angle is 35 degrees, find the length of each leg. So I'm just going to try to sketch me. The length of the hypotenuse is 6. One of the angles, I'm just going to let it be this angle, is 35 degrees. Okay, I could easily calculate the other angle by just doing 90 minus 35, but this is all I'm needing to work with right now. I need to find sides, missing sides. So just for the sake of labeling, I'll let that be side A and side B. So which trig function would give me a missing side over a given side? In relationship to this angle 35, what is opposite over hypotenuse? Good. By definition, sine of theta is opposite over hypotenuse, so sine of the 35 degrees is opposite over hypotenuse, which is b over 6. Now, algebraically, we do what we've done in the past, and we cross multiply right here and get 6 times the sine of 35 degrees is going to give us side B, and that's simply a calculation you go to your calculator with. 3.44 is approximately B, and these are rounded to roughly 2 decimal places. Okay, now the other side that we're missing is an A. I want to try to find the trig definition that's going to give me a missing side I'm looking for over a given side. The safest bet is to always use a given. So what would be adjacent over hypotenuse? Good, cosine. So I'm going to say cosine of 35 degrees is going to be my adjacent over hypotenuse. So adjacent side over the hypotenuse side, which is just going to be A divided by 6. Algebraically, we're going to simplify for the missing term A, and that's going to be 6 times the cosine of 35 degrees is equal to side A, and that's approximately 4.9 inches. So both of these are inches. Inches, let me come back and add inches over here. Since they gave us units, we'll include units. Okay, just to set the stage on these next word problems, application problems, sometimes they'll say angle of elevation, and that's if you're standing here and your line of sight to the object is going to be in an upward direction. And this is if a person, let's say this is on a mountain or top of a tower or something, and the object they're looking at is down here, then the person's line of sight is just, this angle would be considered an angle of depression. Okay, so just to keep that in mind in case in some of the terminology that you may approach, you'll just come into that. So let me just give you the next example, which is going to be an application. Okay, so a tower that's 57 feet tall casts a shadow, 82 feet long. Find the angle of elevation. So we're going to be looking up. Okay, here's my rough sketch. So let's just say here's a tower. Okay, and I'm looking up to the sun up here. Then angle of elevation, see if I can, okay, would be this, and let's say that this is the ground. This would be my angle of elevation. I'm just going to label it theta. Okay. This question's asking, a tower that's 57 feet tall casts a shadow that's 82 feet long. Let's do something about those given pieces of information. What about this 57? It tells me that that's actually the height from there to the ground. So 57 feet, right? So envision this as our triangle. We're basically setting this triangle up right here. So we have side that's 57. What other piece of information did they give us? Shadow, that's 52. So if the sun's here and here's that, we're going to have a shadow that would be on this side, 82 feet, right? Let's go all the way across. So we're basically setting up our triangle that we've had previously. So we have two sides where we could find a third side if we needed to, but what does it ask us for? Theta, right? The angle of elevation. So we need side theta. Which trig function uses the two pieces of given information. Yes, absolutely. So adjacent over opposite. Oh, opposite over adjacent, excuse me, for tangent. So let's do tangent instead of cotangent. That'll be better. So we'll have tangent of angle theta, because that's what we're looking for, is going to be defined to be your opposite over adjacent. Opposite is 57 degree, 57, and the other one is 82. Adjacent is 82. Okay? Now, once again, we're going to use our property. We don't want tangent theta. We only want theta. What allows us to get our angles? What property? Yeah, our inverse tangent. Very good. So if I take inverse tangent of the left side of my tangent theta over here, whatever you do to the left, do to the right side as well. Inverse tangent of my 57 over 82 that was on this side, then this simplifies to just theta. Excuse me, just theta by our property. Theta is going to be, put this in your calculator, tangent inverse. Be sure you put this side in parentheses, and you should get the approximate calculation of 34.804. Let's just round this to approximately 35 degrees.